Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so in these examples here, we have to find some of the missing values. So my first circuit on the left here, I'm trying to find what is the current through this circuit. And I've been given my voltage and my resistance for this bulb. So I'm going to use my equation V is equal to I times R to find an expression for my current. So if I use that equation and rearrange to find current, I get V divided by R as current. That is 4 volts divided by 8 ohms is 0.5 amps. Okay, in my next picture here, I'm trying to find the resistance of my bulb. Okay, and I'm a bit limited with the information that I have so far about my bulb. I don't know what the voltage is over my bulb. I don't know what the current is through my bulb. So I'm thinking that I'm a bit stuck at the minute. So what I'm going to do is I'm going to look at the rest of the circuit, see what information they've given me in the circuit, and see what I can figure out. So what I do have in my circuit is I have this resistor here, and I'm told there are 4 volts over that resistor and it has a resistance of 8 ohms. So what I can do is I can figure out, well, what is the current going through that resistor? So current is voltage over resistance. 4 divided by 8 is 0.5 amps. And then I can figure out, okay, what is the voltage over my bulb? Why? Because I know the total voltage on my circuit is 6 volts and it's a series circuit, so that gets shared between my components. My resistor is already taking 4 of those volts, so I know that my bulb must have 2 volts over it. So what I can say is my bulb has 2 volts over it and a current of 0.5 amps through it. I know the current going through my bulb is the same as the current going through my resistor because this is a series circuit, so the current is the same at every point. Okay, so now I have got my voltage for my bulb and I have got my current for my bulb. I can use resistance equals voltage divided by current. 2 divided by 0.5 gives me 4 ohms resistance. Okay, and in this final picture over here, I'm trying to work out a few things. I'm trying to work out the resistance of my bulb and I'm trying to work out the voltage of my supply. Okay, so the first thing that I'm going to do here is work out the resistance of that bulb straight away because I know the voltage over it is 4 and I know the current through it must be 2 because the current at every point in my series circuit is the same. So 4 divided by 2 gives me 2 ohms. Okay, now I need to try and work out what is the voltage of my supply. And in order to do that, I'm going to need to add up the voltage of my variable resistor plus the voltage over my bulb plus the voltage over my motor. I would be able to do that, except I don't yet know what the voltage over my motor is. But luckily, I do have the current through my motor and I do have the resistance of my motor. So I can just use V equals I times R for my motor. Voltage over my motor, put that little M at the bottom there just to show it's for the motor, equals 2 current times 0.5 resistance equals 1 volt. Good. So now I can add up voltage over variable resistor 3 plus voltage over bulb 4 plus voltage over motor 1 gives me 8 volts in total for the supply of this series circuit. Okay, now to have a look at some parallel circuits. So again, we'll start with our circuit on the left here. And I need to work out the voltage of the supply and then the resistance of that bulb at the bottom. Well, my voltage of the supply I can do by inspection straight away. Because I'm in a parallel circuit, if I look at that first branch with my bulb in it, it has a voltage of 4 volts over it, and it is the only thing in that branch. So the total supply voltage will be equal to the voltage over that bulb. So my supply voltage should be 4 volts. Okay, and now time to think, how can I work out the resistance of the bulb at the bottom? Well, first thing I can do is work out what is the current through that bulb at the bottom. I've got that 3 amps coming from my supply, coming down to the junction and then getting split between the top branch and the bottom branch. The top branch receives 2 amps, so my bottom branch that has my bulb in it will receive 1 amp of current. Good, so I've got its current. Can I know its voltage? Well, yes, I can, because that bulb is the only thing in its branch, and each branch is going to receive 4 volts here. There are 4 volts over that bulb. Okay, so then to work out the resistance, I just need to do resistance as voltage over current. 4 divided by 1 is 4 ohms. Okay, and for my next circuit here, I have a parallel circuit, and I'm trying to work out the supply voltage, and I'm trying to work out the current that goes through that first bulb on the top branch. And I've been given lots of different information. If I hone in to the piece of information that I've been given about the bottom branch, which is that resistor there has a resistance of 2 ohms and a voltage of 10 volts across it, then one piece of information I can figure out is what is the current going through that resistor. And this is a case of me figuring out another piece of information that doesn't seem relevant at first, but will help me to take steps towards getting my final answers. So let me do it. I've got current is voltage over resistance. 10 divided by 2 is 5 amps. Now, this has been quite helpful because now I know the current through the bottom branch is 5 amps. So incidentally, I've also worked out what is the current through that bulb on the bottom branch with that resistance of 3 ohms. And now I can actually use that piece of information to work out, well, what is the voltage over that bulb on the bottom branch? Voltage is current times resistance, so current 5 times resistance 3 is 15 volts. So again, it kind of looks like I'm not really getting anywhere with this question, except now I'm in a position where I have worked out that I have got 10 volts over that resistor in my bottom branch and 15 volts over that bulb in my bottom branch. So what does that help me with? That helps to tell me, well, that must be the supply voltage here. 25 volts must be my supply because that is the amount that that bottom branch has received. I also know that the current, which I was trying to figure out going through that top branch with that top bulb in it, must actually be 5 amps, because if the bottom branch receives 5 amps and the total current going into that junction was 10, then the top branch must receive the other 5 amps as well. Okay, so first question on the left here, what is the energy transferred to a motor with the current running through it at 5 milliamps, voltage over it of 50 volts, and it's left on for 30 minutes? So first things first, let's write out our equation. Energy is voltage times current times time. So let's pick out all of our variables from the question. We have my current, 5 times 10 to the minus 3, because it's in milliamps, so I'm getting it into amps by divided by 1,000. Voltage, 50, and time, 30 multiplied by 60 to get those 30 minutes into seconds. So if I just multiply all those things together, my energy is that current times voltage times time gives me 450 joules. Okay, next question. What is the energy transferred to the bulb below if it's left on for 2 hours? So again, my equation is going to be energy is voltage times current times time. So I need to figure out what is the voltage, current and time in this question for my bulb. The voltage over my bulb is relatively straightforward. This is a series circuit and it's in series with that resistor. There's a supply of 6 volts, but my resistor is using 4 of them. So my bulb must have a voltage of 2 volts over it. And then how to figure out the current going through my bulb. Well, the current going through my bulb will be the same as the current going through my resistor, because this is a series circuit, so my current's the same at each point, which means that I can just work out the current going through my resistor. That's easier for me because I already know the voltage over my resistor and the resistance of my resistor. So current is voltage divided by resistance. 4 over 2 is 2 amps. The time here, it's told me in the question that it's 2 hours, but I need it in seconds. So 2 times 60 to get it into minutes, times 60 again to get it into seconds. Cool, so my energy is a lot of 2's, just coincidentally. 2 times 2 times 2 times 60 times 60, 28,800 joules. Okay, a kettle is transferred 250 kilojoules of energy in 5.4 minutes. What is the power of the kettle? Well, power is equal to energy over time. There are many different power equations. I know I need to be using this one because in the question they've given me an energy 250 times 10 to the 3 kilo joules, and they've given me a time 5.4 times 60 to get those minutes into seconds. So then it's just a case of plugging into my equation. Power equals that energy divided by that time, 772 watts. Okay, then it says the current through the kettle is 13 amps. What is the voltage over the kettle? What information do I have in this question? I have energy, I have time, I have current, and I'm trying to work out the voltage. I've also just worked out the power. So which equation have some of those things in? I've got my equation for power is equal to current times voltage, and therefore my voltage is equal to power over current, and I have both those things. Power is 772 and current is 13, so my voltage is 59. Okay, next question. What is the power of the following components? Component 1, 2 and 3. So my first one is that bulb up there, and through that bulb I have a voltage which should be equal to the voltage of the supply because it's in parallel, 8 volts, and I can see my current going through that branch is 2 amps. So power is voltage times current, 8 times 2 is 16 watts. Okay, number 2, my bulb in the bottom branch, I have a voltage that is written for me over it, it's 2 volts. And the current I can figure out because there's 5 volts coming into that junction, 2 amps go along the first branch, so 3 amps must go down the second branch. Power is voltage times current, 2 times 3 is 6 watts. And final one here, my resistor, I have, well, my voltage should be 6 because I have a total of 8 volts over that bottom branch and 2 are being used by the lamp, which leaves 6 for my resistor. And I know my current from the previous example through that branch is 3, so my power, voltage times current, 6 times 3 is 18 watts. Okay, what is the power wasted through a wire with the resistance 50 ohms and the current of 15 amps through it? So again, basically the hardest part of this question is what equation should I use? And I'm going to use the equation P equals I squared times R. Why? Because if I write out what I've got in my question, I have got a current I of 15 and I've been given a resistance R of 50. So that's the only equation that has those two variables in it. My power then is 15 squared, or 15 times 15 multiplied by resistance 50, 11,250 watts. I like to write the 15 times 15 there instead of just 15 squared because it makes me slightly more likely to type it correctly into my calculator. Okay, next, what is the current running through a bulb with a power of 40 watts and a resistance of 8 ohms? So again, something that relates power, resistance and current together must be this equation here. P is I squared R. And let me identify my stuff. Power is 40, R is 8, therefore 40 equals I squared times 8, or 40 divided by 8 equals I squared, so that is 5 is equal to I squared. So then to square root my I, 2.2 amps. Okay, a computer has a power rating of 2000 watts and computer B has a power rating of 1500 watts. Sam says computer A is more efficient. Do you agree? Explain. Well, obviously computer A has a higher power rating, so the question is, does that mean it's more efficient? And the answer is not necessarily. I would then, if I were trying to prove this in my exam, firstly get very straight what is the formula or definition for efficiency. And we know that efficiency is useful power over total power. Those 2000 and 1500 watts, these are my total powers. So it's not really telling me necessarily something about the efficiency as much as the total power these computers are using. So for example, the 2000 watt computer could be that it is actually wasting more energy per second to heat, and they both have the same amount of useful power that they're using. So not necessarily, just be careful, your power ratings are not telling you about the efficiency of your device, just the amount of energy they use per second.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, any tips and tricks for this section? So first is your power. You have energy over time, you have I squared times R, you have V times I. You have a lot of equations. For power alone, you have 3 different equations. So if you're ever stuck in a question and you don't know what equation to use, your first step should always be write down what variables you have been given in your question and what variable you are looking for. Hopefully with those letters written out, you can then go to your formula book and check which formula has all those variables in. Okay, I can use that one for this question. And if you don't find a formula in your formula book with those letters in, which formula can you use to maybe figure out a different variable? And then you might be able to use that variable along with your other information to find your final answer. So it doesn't normally get that complicated in your GCSE, but that's always the first step, how to choose, write all your stuff out first. It kind of leads me on to my next one here, which is find irrelevant stuff it might help. If you are doing a circuit-based question and you're looking for, let's say, the resistance of something, and you can't find it straight away, but you can find maybe the voltage over something else, just do it. It might then help you to find another piece of information that you need so that you can find the piece of information that you are looking for. I've actually accidentally written, there we go, circuits, find I, R and V. The thing I wrote above, P is I squared R, I've actually mentioned it in the video already. If you're using that equation I squared R, I would write I times I to just make it less likely in your calculator to make a mistake. Finally, I feel like I always say this one, but it's just as important in these equations, your time is in seconds. So that is one thing that they probably will do somewhere over the 2 papers is write a time in minutes or hours, and you need to convert it into seconds here before you can use it in these equations.